Welcome to part 2 of the Diet Calc Semester 1 review. Problem number 5 from the review packet saying, and don't be troubled by the way by this notation, it says f of x equals, this is an alternative way used in other parts of the world, says that the function f takes all x's and turns them into these numbers. We'll see again we have a quadratic function, it's going to be a parabola, but I don't know the y-intercept, I don't know the k value. But in spite of that, it's asking me to find the derivative. When it says write down, it implies that it's probably going to be a pretty easy process. We just take the derivative of this function using the power rule. 3 times 2 is 6, drop the power by 1. 5 times 1 is 5, drop the power by 1, that gives us x to the 0. And of course remember k is a constant, so that's like the number 3. If I take the derivative of 3 times x to the 0, take the derivative, we get 0. The slope of a constant is 0. So, simple enough, part A, found the derivative. Now, it says the equation of the tangent to the graph of f at p is 7x minus 9. There's more information there than it seems. One of the things I know is that when x equals p, which is an unknown number, which I need to find, whenever x is p, the slope of the tangent line is going to be 7. So that's some good information to go off of. F prime of p has to equal 7, the slope of the tangent at p. So, I evaluate f prime of p, and it generates this equation. 6p minus 5 equals 7. 6p has to equal 12, add 5 to both sides, and therefore p has to equal 2. Mission accomplished, I found part B, letter P. So in other words, when x is 2, the slope of the tangent line is going to be 7, and now I need to find the value of k. Well, here's one thing I know, that when p is equal to 2, I can find the point on the line, on the tangent line. So y equals 7 times 2 minus 9, y equals 5. So 2, 5 is not only a point on the tangent line, 2, 5 is also a point on f of x. Because the tangent line crosses this function at the exact same point, 2, 5. So I simply find f of 2, which leaves out the value of k, but I know 5 is going to be the result. So I add up all the numbers, solve for k equals 3. To verify that all this is true, I have the function f of x equals 3x squared minus 5x plus 3. P is 2, the k was 3, so that completes my quadratic function. I put this into Desmos, verify this is the quadratic function that I was supposed to be generating when k is equal to 3, and at the point 2, 5, the line 7x minus 9 does indeed go tangent to that function. So, all these criteria are met, I have the right answer for sure. Now, this is a little bit of a review in Algebra 2. This is a way of writing quadratic functions as linear factors. If you remember, if we wanted to find the x-intercepts of this function, we would factor a quadratic into these two factors, and then solve for x, which would be p and q. So really, since 1 is one of the x-intercepts and 5 is the other x-intercepts, those are my p and q values. Simple enough. The second question was asking for the equation of the axis of symmetry. To do that, I find 5 and 1's midpoint. 1, 2 over, 1, 2 back. They converge on x equals 3. The equation of a vertical line, recall, x equals. So x equals 3 is the equation of the axis of symmetry. Now I'm asked to find the equation in which is called vertex form, where hk represents the vertex of the parabola. This is in intercept form. I'm going to take that given form with the p and q values in place, and I know that when x equals 3, I'm going to be at wherever my vertex is. Looks like it's going to be negative 4 according to the graph. To verify, put in 3 for x, put in 1 for p, and 5 for q, and I get y equals negative 4. So 3, negative 4 is the vertex of the parabola, therefore x minus 3 squared minus 4 represents the equation in vertex form. This equation is the same equation, or represents the same parabola, same set of solutions as this equation does. It seems to be a clue that I use that form to make it easy to find dy dx. So I take the derivative using the chain rule, which is very simple. We get 2x minus 6. So all that stuff is pretty elementary. Now here it's just saying that there's a tangent line. Let t be the line tangent to the curve at the point 0, 5. So there's this point 0, 5, which is the y-intercept of the parabola, and there's going to be a tangent line. I just need to find the slope of that tangent line, so I take the derivative when x equals 0. Putting in 0 for x, I get negative 6. That matches what I see on the graph. If we go down 6 over 1, we're back on the line. That's how steep this line appears to be. The y-intercept is 5, 0, 5. Therefore, the equation of the line is going to be y equals 5 minus 6x. Excuse me, all of this can be verified. Here are both equations, and I see only one graph, which means both of these equations represent the same parabola. I also see the tangent line, 5 minus 6x, is indeed tangent to the curve at the point 0, 5. So, work done. One more for this second set of the video. The first, we're given a cubic function, and just reading ahead, I can see that I'm going to be asked to take the derivative using first principles. What A is doing is going to help us out because we're going to have to find x cubed in order to take the derivative using first principles, and that's x plus h cubed in this case. So it's asking us to expand that ahead of time. So that's just algebra 2 or algebra 1. Notice I already knew how to square x plus h. It's x squared plus 2xh plus h squared. If you needed to FOIL that out, that's fine. I'm setting this up using traditional multiplication, setting it up vertically. So now I have h times h squared, which is h cubed, and then I have h times 2xh, which is going to be 2xh squared. I'm going to have h times x squared, which is x squared h. Here, now we're going to multiply the x. It's like distribution. First we distributed the h into all three of these terms. Now we're going to distribute the x times h squared, and that lines up. We have 2xh squared plus another 1xh squared. Here we have x times 2xh, which lines up here, and finally we have x times x squared, which is x cubed. All of these lined up perfectly so that they're with like terms, so I simply add, and I have now expanded the expression. Now to take the derivative using first principles, I need to find x plus h. Limit as h goes to 0, so here's my x plus h. I substitute that in for x cubed, so we have x plus h cubed. The next is going to be minus 4x plus h, and then my plus 1. Then I need to subtract f of x. Let's use green for x. Got Christmas colors going. Here we have x cubed minus 4x plus 1, and then that's all over h. Now, luckily for me, I expanded x plus h cubed already, so I'm going to write in that expansion. Then I'm going to distribute the negative 4, and then I'm going to keep the 1. And finally, I'm going to distribute the negative into here. Negative x cubed plus 4x minus 1, that's all over h. You can see all the terms that subtract out. That's what's supposed to happen, and if we did everything right, we'll be left with terms that only have h's in them. That enables us then to divide everything by h. And now I got the h out of the denominator. When I let h approach 0, I'm left with 3x squared minus 4. That's what we were asked to show, so that's what we did. We can obviously check that with the power rule, nice little shortcut, but this was a skill question. Now we got some other questions going on. It says that the tangent to the curve at 1, negative 2 is parallel to the tangent at point Q. In other words, this cubic polynomial is going to have a tangent line that's going to be parallel to another tangent line somewhere else. So, what do I know? I know that f prime of 1 is negative 1. Why does that matter? Well, the line I'm looking for is parallel, which means the line I'm looking for has a slope of negative 1. If the slope is negative 1, then I can set negative 1 equal to my derivative and find the other place where the slope is also negative 1. In other words, this derivative will tell me the slope of the tangent line. I want to know when else will the tangent line have a slope of negative 1. So I ask it, equation, when do you equal negative 1? When we solve, we divide both sides by 3, take the square root of both sides, and we get plus or minus 1. Now we've already established that when x equals 1, that the slope is negative 1. Now we know that when x equals negative 1, that the slope will also equal 1. Or negative 1, sorry. So, P is at f of 1, therefore Q is at f of negative 1. So I just evaluate f of negative 1 into the cubic, the original function, and I get 4. So Q is the point negative 1, 4. Finally, the graph is decreasing between P and Q. This is like the curve sketching that we just did recently. First thing I do is I find when is the derivative equal to 0, and that's when x is equal to plus or minus 2 over the square root of 3. Notice I just divide both sides by 3, take the square root of both sides, don't forget the plus or minus. So the P is the lesser of the two, and then the q is the larger of the two. And when I put in the calculator, I get that p and q, 2 over the square root of 3, is approximately negative or positive 1.155, which matches my graph and shows the function decreasing between those two p and q values. Alright, so we'll move on to the next problem, the next video, the next two problems will be on the final video of this series. Thanks for watching.